In every car that moves across the road, there is a heart beating silently under the hood, the engine. It's not just a machine made of metal, it's a masterpiece of science, engineering, and precision. When you press the accelerator, you're not just increasing speed, you're commanding thousands of tiny explosions to happen in perfect harmony, pushing pistons, spinning shafts, and transforming chemical energy into motion. But how does all of this really work? To understand a car engine, we need to look deep inside and see how air, fuel, fire, and motion come together to create something so powerful yet so controlled. Every engine starts with air and fuel. Gasoline, or petrol, is a hydrocarbon, a chemical compound made of hydrogen and carbon atoms. Air, on the other hand, is a mix of gases, mostly oxygen. The magic begins when these two mix together in the right ratio. Inside the engine, this mixture is pulled into small chambers called cylinders. Imagine each cylinder as a mini power plant, waiting for a spark to come alive. The engine's cylinders can vary in number. Some cars have 4, some 6, some 8, or even more. The more cylinders, the smoother and more powerful the engine generally becomes. Now, let's imagine what happens inside a single cylinder. At the top of the cylinder is a small space closed by a valve. Inside it, a piston moves up and down like the plunger in a syringe. The piston is connected to a crankshaft through a rod, so every time the piston moves, it turns the crankshaft. The crankshaft is the part that ultimately sends rotational motion to the wheels. But the piston doesn't just move randomly, it follows a very precise dance called the four-stroke cycle: intake, compression, power, and exhaust. The first part of the dance is the intake stroke. When the piston moves down, it creates a vacuum, and the intake valve opens. Air and fuel rush in together, filling the cylinder. This is like taking a deep breath before you blow out candles. The engine is breathing in, preparing for the explosion that's about to happen. Once the cylinder is full, the intake valve closes, trapping the mixture inside. Then comes the compression stroke. The piston moves upward again, squeezing the air-fuel mixture into a much smaller space. This compression makes the mixture dense and ready to burn more efficiently. The tighter it's compressed, the more powerful the explosion will be later. When the piston reaches the top of its movement, known as top dead center, the mixture is now under high pressure and waiting for one final trigger, the spark. That spark comes from the spark plug, a small device that sits right at the top of the cylinder. The plug delivers a tiny electrical spark at just the right moment. That spark ignites the compressed mixture of air and fuel, and instantly, a controlled explosion takes place. The burning gases expand rapidly, forcing the piston down with tremendous power. This is the power stroke, the moment the engine truly does its work. The force of that explosion is transferred through the piston to the crankshaft, which then turns, creating rotation. This rotation is what eventually makes your car move. After the power stroke, there's one more step, the exhaust stroke. The piston moves up again, this time pushing out the burned gases through the exhaust valve. Those gases travel out of the cylinder, through the exhaust manifold, into the catalytic converter, and finally out of the tailpipe as exhaust. And then, the whole cycle starts again: intake, compression, power, exhaust, happening dozens of times every second in every cylinder. While all of this sounds like chaos, it's actually an incredible display of timing and precision. The opening and closing of valves, the movement of pistons, and the timing of spark plugs must all be perfectly synchronized. That synchronization is handled by a system called the timing belt or timing chain. If even one part moves a fraction of a second too early or too late, the engine could misfire, lose power, or even get damaged. So inside an engine, timing is everything. But an engine doesn't work alone. It needs support systems, like the cooling system, lubrication system, and fuel system, to keep it running smoothly. The cooling system keeps the engine from overheating. As the engine runs, it gets incredibly hot, temperatures can reach over 2000 degrees Celsius during combustion. Coolant, a mixture of water and antifreeze, circulates through the engine block, absorbing this heat and carrying it away to the radiator. The radiator then releases the heat into the air, keeping the engine at an ideal operating temperature. Without cooling, the metal parts would expand too much, seize up, and destroy the engine. The lubrication system is equally important. Every time the piston moves, it slides against the cylinder wall, and metal parts spin and rotate. Without oil, this friction would create heat and wear out the parts quickly. The engine's oil pump circulates engine oil through narrow passages, coating all the moving parts with a thin layer of lubricant. This reduces friction, prevents overheating, and ensures the engine lasts for thousands of hours of operation. When oil gets old or dirty, it can no longer protect the engine properly, which is why regular oil changes are essential for any car. Meanwhile, the fuel system is what brings the gasoline to the cylinders in the right amount and at the right time. Modern engines use fuel injectors instead of carburetors. These injectors spray a fine mist of fuel directly into the intake air or directly into the combustion chamber. This precise control of fuel improves efficiency, power, and reduces pollution. Sensors constantly measure things like air temperature, pressure, and oxygen levels in the exhaust, allowing the engine control unit, ECU, the engine's brain, to adjust the fuel mixture and timing in real time. It's like having a small computer making millions of calculations per minute to ensure the engine runs at its best. If we zoom out from the cylinder and look at the whole engine, what we see is an intricate network of components all working together in perfect coordination. The pistons move the crankshaft connects to the flywheel smooths out the rotation, and then the power moves through the transmission to the drive shaft and finally to the wheels. It's a chain of energy transformation, from chemical to mechanical, from motion to movement, from spark to speed.